Now, like I said, this naming of what? Organic compound. Yesterday, I gave rules of naming. Okay, there's a nomenclature where you are naming compound. Nomenclature means the system of what naming. If it's nomenclature of organic compound, means the system of naming organic compound. If it's nomenclature of arcane, means the system of naming arcane. If it's nomenclature of arcanum, means the system of naming what? Arcanum. Now, like yesterday, I told you that whenever you are naming organic compound, there are some rules and principles you must adhere to. Are you following? And number one, I told you that you must identify the parent chain. The parent chain is the longest one carbon chain. Are you following? Now, we have several questions here. Okay, once we are done naming this, they will push me to hydrocarbon. Are you following? Alright. Now, whenever you are naming, I said that you always follow the word, the root word. And what are the root words? We have root words. Now, the root word, number one is mix. Number two is X. Number three is proof. Number four is what? Goods. Number five is what? Thanks. Number six is what? X. Number seven is what? X. Number eight is what? Ought. Number nine is what? None. And number 10 is what? Deck. If it's a K family, like I said before, this one be called Met A, X A, Group A, Root A, Paint A. All what you don't need to be doing is to be adding what? A and E. Because arcane, the parent name end with what? A and E. If it's arcane, the parent name end with what? E and E. So you'll be adding what? A and E. So this one stands for, this one is the word, the root word, words. Okay? Now, this is it. In naming the first one, first thing you have to take note of is what is the functional word group. I've told you yesterday that the functional group defines the word, the structure of a particular family. It tells you which family that particular structure belongs to. Are you following? Yes. Now, just like this one, these are carbon to carbon single bond, right? If it's carbon to carbon single bond, you know that the functional group there is what? Alkane. Are you following? The functional group is what? Alkane. Alkane. All right. Now, this root word, they are the numbers of carbons. Hello? The root word, they are the numbers of what? Carbon. If it's one carbon, it's known as mix. If it's two carbon, it's known as X. If it's three carbon, it's known as pro. If it's four carbon, it's known as. If it's five carbon, it's known as. If it's six carbon, it's known as. If it's seven carbon, it's known as. If it's eight carbon, it's known as. And if it's nine carbon, it's known as. And the last one, if it's 10 carbon, it's known as what? Dead. Are you following? Now, just like this first one now, if you count the numbers of carbon, we have 1, 2, 3, 4. Is it not 4?
Yes.
Is it not 4?
Yes.
So if it's 4, it's known as what? Boots. That means the name of this is Boots. Since it's arcane members, it becomes what? It becomes what? Now, likewise, if you add something like this, maybe you add double bond now. Ish. Now, how many is this? Is it not 4? Yes. You can see now this one has a double bond. Yes. If it's a double bond, that means it belongs to what? Arcane family. Are you following? Yes. Since it's 4, it's called boot. Because of the double bond, they become what? Butane. It become what? Butane. This one is known as what? Butane. It's butane because it's carbon to carbon was single bond. Either you call this one butane, you call it but1-ene, or you call it what? But1-ene. But1 what? In. All right. So hope this naming is clear. Yes. So let's move to the next one. Now, like what I told you guys yesterday, there's what is called catenation. Catenation means what? The linking of what? Carbon atoms to what? Together. Now, when you are counting the longest carbon chain, you are not counting the hydrogen, you are counting the what? The carbons. Are you following? Now, like what I told them yesterday, I said we have long chain, we have straight chain and branch chain. Are you following? Your long chain is sitting as straight chain. Now, when it comes to organic chemistry, there's nothing like front or back. Are you following? The front can be the back, and the back can be the what? The front. Okay. Now, if you are counting the longest carbon chain, if you count for this one, you can. If you observe, this is how the branches go. The carbon link is start like this, and when it gets here, then it move upward, right? Then as it's going, if you observe this, it moves downward, is it not? And the thing is still what? Going. So this one is the carbon linking. So if you want to count the numbers of carbon now, are you following? Either you count from here to this place, or you count from here to this place, or you count from here to this place, which is straight. Are you following? Yes. So if you are counting this now, this one is 1, 2, 3, and what? 4. And 4, is it not? Yes. So if you are counting like this now, which is like this, it becomes 1, 2, 3, 4, 5, 6, and what? 7. Are you following? Then if you are not counting like this, it becomes 1, 2, 3, 4, 5, and what? 6. Is it not? Yes. So which is the longest? 7. Is it not 7? Yes. That means we have to count like this. Now that you've identified the parent chain, which is the longest carbon chain, the next thing that comes to your mind is, which side will I start counting from? Should I start counting from here, or should I start counting what? From the down? Are you getting me? For you to know the side you have to count from, you have to put the substituent in consideration. Are you following? The substituent, there are other group that is attached to the longest carbon chain. Now, if you are taking this one now as the longest carbon chain, now are you following? Outside the hydrogen, if you observe, we have chlorine here, is it not? We have chlorine from this other side, right? That's all, now, is it not? So all those other chain that is attached to the longest carbon chain, you take it to be your substituent. Aside from this chain, now you can see we have another chain going like this, right? And we have another one going like this, right? And we have another one going upward, is it not? So this one like this is a substituent. Why this one like this is also what? A substituent. And this one like this is also what? A substituent. Are you following? Now, if you want to determine which side to start counting from, you start your numbering from the side that is closer to the substituent. Are you following? You start your numbering from the side that is closer to the what? To the substituent group. Alright. Now this is it. If you want to start counting now, if you observe, if you count from here, from this side, this is 1, this 2, this 3, this 4, then 5, 6, and 7. This is my first substituent group, which is this one, right? Is in which carbon? Is in which carbon? Alright. Then let's count from this other side. So if you are counting from here like this, we have 1, 2, 3, 4, 5, 6, and 7. So the substituent is where now? It's also in carbon-3, right? Yes. Now, if you have substituent in equivalent position, that is in the same position of carbon, are you following? When counting from this, I have it in carbon-3. When counting from the down, I have it in what? In carbon-3. How do I now know which side to start counting from? For you to determine which side to start counting from, you now use the what? The base letter from the substituent. The substituent group here is methane. The substituent group there is what? Methane. And the substituent group here is what? Chlorine. So using the base letter between M and E and C alphabetically, which one comes first? C. Is it not C? Yes. Since C comes first alphabetically, if you want to start your numbering now, you start counting from the what? From the down and not from this other side. Are you following? Yes. Because alphabetically C comes first. Are you following? Yes. Alright. Now, if we want to start our numbering now, it becomes 1, 2, 3, 4, 5, 6, 7. The main reason why this one is called methyl, okay? Methyl, just like other hydrocarbon, take note, methyl does not have a functional group. Are you following? Methyl was generated from alkane. So when alkane loses one hydrogen, hello, when alkane loses one hydrogen, become what? alkyl. It become what? Alkyl. It become what? Alkyl. When alkane lost one nitrogen, what you are going to have is what? Alkyl. For example, if you have this H, and H. This is one carbon, right? Yes. This is alkane, right? Yes. One carbon like this is called what? Methane. One carbon is called what? Methane. Now, if you remove this hydrogen, is this still complete? No. Is this still methane? No. So it become what? Methyl. Your methyl, the parent name end with YN. All what you just need to be doing is to be adding YN to all these ones. Are you following? Yes. So this one become methyl. Then this one will become what? Ethyl. This one become what? Propyl. This one become what? This one become what? Methyl. etc. Are you following? Yes. Alright. Now this time around, if I want to start my numbering now, I'll start counting from the word from the down, right? Yes. So this become 1, 2, 3, 4, 5, 6, and 7. So now, once you are done identifying the parent chain there is what? 7. And 7 is what? X. 7 is what? X. 6 is carbon to carbon single bond. It become what? X8. It become what? X8. Now, this is the parent chain. This is the parent what? Chain. Now, once you are done identify the parent chain, the next thing, you try and identify the position of each of the substituent group. Are you following? You try and identify the position of what? Each of the substituent group. Now, if you observe now, your chloro is in which carbon? 3. So that means we have 3 what? Chloro. Are you following? Yes. Then, we also have, if you observe, this one now is attached to this carbon 4, right? Yes. This one is attached to carbon 4, right? Yes. Now, this one is alkyl, right? Yes. How many carbon is it? 2. If it's 2 carbon, it become what? Ethyl. It become what? Ethyl. It become what? Ethyl. So that means your ethyl is attached to which carbon? Carbon 4. Your ethyl is attached to which carbon? Carbon 4. That's carbon what? 4. So that means we have 4 what? Ethyl. Are you following? Yes. Then the next thing now, our methyl is in which carbon? Carbon. So that means we have 5 what? Methyl. 5 methyl. Is it not? Yes. We have 5 what? Methyl. Now, we are done identifying all of them. The next step now is to join everything to work together. When you are naming organic compound, there is no space in naming. Are you following? Now, if you are like to separate your number from the word, are you getting me? You use a dash. Then if you are separating number from number, let's assume you are like 2,2-dimethyl. You separate a number with a comma. You separate number from word with what? A dash. So when you are naming, you don't space them. Are you following? You do those dash and comma to link everything to what? Together. Alright. So if you are to join everything yes together, you name the substituent group first, followed by the parent word chain. So you arrange them in alphabetical word order. You arrange them in what? Alphabetical order. Using the base letter. Using the base what? Letter. The base letter there is the first letter for each of the words. Are you following? Yeah, we have C. Yeah, we have E. Yeah, we have N. Between C, E, and N, which one comes first? C. C comes first. That we have to name this first. Followed by what? E. And followed by what? N. So if you want to lead them together now, it becomes 3 dash. Then we have chloro. Then dash. Because number is coming next. Are you following? Then we have 4 dash ethyl. Are you following? Then dash 5 methyl. Then what's now the parent name? Then X8. So that is for that. Alright. Don't worry, I'll give you a chance to write. So the next one, let's move to this. If you observe now, this one we have carbon to carbon double bond, right? Yes. Since you have carbon to carbon double bond, are you following? It become what? Alkane. So that means this very compound belongs to alkane, right? Yes. This very compound belongs to what? Alkane. Are you following? Yes. Now, whenever you have a substituent and a functional group in an organic compound, you start your numbering from the side that is closer to the functional group and not the substituent. Are you following? But if there is no functional group, you start your numbering from the side that is closer to the substituent group. Are you following?
Yes.
Yeah, we have a functional group and we have what? The substituent. My substituent there is what? Chloro. My functional group there is what? Is the double bond, which is alkene, right? If I want to start my numbering, I'll start counting from what? From the side that is closer to the double bond. Comparing this side and this side, which side is more closer to the double bond? It's the right hand side, right? So if I want to number now, start numbering from the right hand side. So here become 1, 2, 3, 4, 5, and 6. That means the parent name is what? The parent name is what? Right, Enzim. As what? As what? Why is it Enzim? Because it's alkene. Because it's what? Because it's what? Alright. Now that you've identified the parent word's name, another thing that should cross your mind is the position of the word substituent. Are you following? And the substituent group there is attached to which carbon? That means I have 4 words. I have 4 words. Then another thing that comes to your mind now is the position of the double bond. Is the position of the what? Is the position of the what? Now, in terms of the position of the double bond, please take note. You are counting carbon to carbon bond, not hydrogen to carbon bond. You are counting what? Carbon to carbon bond, and not hydrogen to carbon bond. If you want to know the position of this now, you don't count hydrogen to carbon bond. Are you following? Instead, you count carbon to carbon bond. Using carbon to carbon linking, this is my first bond, is it not?
Yes.
And this is the what? Second bond. Then we have third, fourth, and fifth, right?
Yes.
So that your double bond is in which bond? Is in carbon, is in a double bond. The double bond is in which bond? The second, right?
Yes.
So this is the second bond, right?
Yes.
Now, if you want to name this now, you don't just name it Enzim. Are you following? The main reason why we name it Enzim because it 6 words. It 6 words. It 6 words. Now we want to attack the position of this word double bond. The double bond is in 2, right?
Yes.
So if you want to name this now, you name it as S2E. You name it as what? S2E. How do you know that it's Enzim? Because there is a double bond there. Double bond, the family is known as what? Alkene. The parent name ends with E-N-E. Are you following? So when there is no double bond there, you call it what? Enzim. You call it what? Enzim. If there is a triple bond, you call it what? Enzyme. Are you following? Alright. So you cannot call it what? S2E. These 2 here, you are telling us that the double bond is the number 2 bond. Are you following? Which is carbon to carbon bond. This is 1 and this is what? 2. So if you want to join everything together, you name the word, the substituent followed by the parent's name. Are you following? So this one become S. Sorry, they become what? 4-chloro. S2 what? S2 what? Any question there? Let's move to the next one. So look at this. If you observe this very one, we have double bond and we have what? Triple bond. We have double bond and we have what? Triple bond. Now, please pay attention. Since you have double bond and triple bond, the question is, which side should I start counting from? You start your counting from the side that is closer to the triple bond. Are you following? Yes. You start your numbering from the side that is closer to the word? Triple word bond. Now, even though you have your triple bond in the middle and you have your double bond in the first bond, you start your numbering from the side that is closer to the triple word bond. Why? Because your triple bond is more reactive than the double bond. Because if it undergoes additional reaction, your triple bond has to break down towards a double bond, from double bond towards a single bond. But if it's a double bond, if it undergoes additional reaction from double bond to your break down towards a single bond. Are you following? Yes. All right. Now, if you want to start our numbering now, this one is 1, this 2, 3, 4, 5, 6, 7, and 8. We also have another carbon here, right? That I can still count like this, is it not? So this is 1, 2, 3, 4, 5, 6, and 7. That means the longest chain is how many?
8.
The longest chain is how many?
8.
What will I do to this? I'll take this one to be my what?
Substituent.
I'll take this one to be my what?
Substituent.
I'll take it to be my what?
Substituent.
Are you following?
Yes.
Alright, since the parent name. Now, so the parent name become what? How many is it? They become us. They become what?
Us.
They become what?
Us.
Now please pay attention. 4 in 4 in 4 in 2 what? 2 what? 2 what? Oh yeah, pronounce it again.
6 meter of 4 in 2 I.
Again.
6 meter of 4 in 2 I.
Is that clear?
Yes.
Alright. So for this other one, if you observe this, there is OH group, right? OH group is what? Alcohol. Is it not? That means this particular family belongs to the family of alkanol. Belongs to the family of what?
Alkanol.
And alkanol, the parent name end with what? OH. The parent name end with what? OL. Are you following? Now, your alkanol was gotten from what? Alkane. Now, if you remove the last letter of your alkane, now this is it. We have alkane. We have what? Alkane. So if you remove this last letter E, you replace it with what? OL. It become what?
Alkanol.
It become what?
Alkanol.
All like this and there's nothing like mate all at all. Because I say it's OL, that is why you name alkane first, remove the last letter in alkane and replace it with what? OL. Definitely this one is methane, right?
Yes.
If I remove the E, become what? Methanol. Methanol what? All. Then ethanol, propanol, butanol, methanol, hexanol, ethanol, octanol, nonanol, and decanol. Are you following? Alright. Now, if I want to start my numbering now, the longest carbon chain, I say you start counting from the side that is closer to the functional group, right?
Yes.
If you share the carbon linking, I have 1, 2, 3, 4, 5, 6, and 7, right?
Yes.
I can also count like this. This is 1, 2, 3, 4, 5, 6, and what? 7. Don't forget, in this place I have 2 carbon, right?
Yes.
So if I want to count like they become 1, 2, 3, 4, 5, 6. That means the longest chain is what? 7. 6 is 7. 7 is called what? X. 7 is called what?
X.
7 is called what?
X.
So if I have to number now, it becomes 1, 2, 3, 4, 5, 6, and what? 7. Are you following? Alright. Now, let's identify the position of the substituent. This one is a substituent, is it not?
Yes.
And this one is also what? A
Substituent.
substituent. 2 carbon is known as what? Ethyl. 2 carbon is known as what?
Ethyl.
My ethyl is attached to which carbon?
Carbon.
That means I have 4 what?
Ethyl.
I have 4 what?
Ethyl.
4 ethyl. Now from here, my methyl is attached to which carbon? That means I have 6 what?
Methyl.
6 what?
Methyl.
Alright. And what the parent name? 7 is what?
S.
7 is what?
S.
Alright. And my functional group, which is OH, is attached to which carbon?
Carbon 1.
Is attached to which carbon?
Carbon 1.
That means I have 1 O. We call it what? 1 what? We call it 1 what? 1 what? If it is attached to carbon 3, it becomes 2 what? If it is attached to carbon 3, it becomes 3 what? Alright. So that means F1 or you call it etan 1 or sorry. Because it's alkanol, right? It becomes etan 1 what? Or. Now you can simply call it ethanol, just like 1,000 naira and 1,000 naira. Are they not the same thing?
Yes.
So either you call it etan 1 or you call it ethanol. heptane what? All right, so let's join everything together. So between E and M, which one do you name first? E. So it become 4-ethyl. 6 what? Methyl. Heptane 1 all. Heptane 1 what? Oh, yeah, pronounce it again.
4-methyl, 6-methyl, heptane 1 all.
Or if you don't want to name it heptane 1, how do you not name it?
4-methyl, 6-methyl, heptane all.
Is that clear?
Yes.
All right, yeah.
I'm using YL, but there's no triple bond. You said if it's triple bond.
YL. Triple bond is YLE. YL is alkyl. If you remove one, if you remove one hydrogen from alkane, normally this one, ethene, like this is known as what? Ethane, right? Like this is known as what? This one is C2H6, is it not? If I remove one hydrogen, is it still ethane? It becomes what? Ethyl. When alkane lost one hydrogen, it becomes alkyl. Alkyl end with YL. This one becomes methyl, ethyl, propyne, butyne, pentyne. Are you following? If yours is not C2H5, so if you remove one hydrogen, is it not C2H5? C2H5 is known as what? Ethyl. Just like this one, as this is CH3. If it's CH4, it's maintained. Since I remove one hydrogen, it becomes what? Now, normally, this where carbon is, you ought to add your hydrogen there. That is why if you observe now, it's just one carbon, it has 3 hydrogen surrounding it. The other part ought to be hydrogen, but there's no longer hydrogen, now has your what? Carbon. So that's why it's CH3. And CH3 there is what? Methyl. If it's C2H5, it becomes what? Ethyl. Is that clear? Alright. So we have 2 left. Look at this. The longest carbon shade there is how many?
6.
The longest carbon shade is how many?
6.
6. So yeah, let's confirm it. This is 1, 2, 3, 4, 5, 6. Is it not?
Yes.
If I count like this, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. It's still 6, right?
Yes.
6 is known as what?
Yes.
It's single bond, right?
Yes.
It becomes ethane. It becomes what?
Ethane.
Alright. Another thing now. Which side should I count from? I say you start counting from the side that is closer to the substituent, right?
Yes.
Compare the right and the left hand side. Which side is not closer to the substituent?
right.
The right hand side, is it not? So if you want to know, I become 1, 2, 3, 4, 5, and 6, right?
Yes.
So this is methyl, right?
Yes.
Methyl is attached to which carbon? That means we add 2 what?
Methyl.
We add 2 what?
Methyl.
Now if you observe here, I have 2 bromine attached to carbon 4, right?
Yes.
Now, you don't name it as 4 dibromo. No. This bromo is attached to which carbon? 4. This other bromo is attached to which carbon? 4. If you add the same substituent group appear, you use a prefix to indicate it. Either di, tri, tetra, and so on and so forth. Are you following? Since you have the same thing, bromo, you name it as what? Dibromo. If you add 3 bromo, you name it as what? 5 bromo. If you add 4 bromo, you name it as what? Tetra bromo. Alright. Now, from here now, this one is stating as 4, 4. Hello? It's stating as what? 4, 4. Why do I name it 4, 4? Because this 4 is for this, and this other 4 is for this. Are you following?
Yes.
So you name it as 4, 4. Sometimes this one can be here. Maybe you might name it as 4, 5. Are you following?
Yes.
Because both of them appear in the same word, carbon. Are you following?
Yes.
So that's why we name it as 4, 4. Then dibromo. Di what?
Bromo.
Di what?
Bromo.
So you cannot join everything to what? Together, yes?
What if it's chloro? Like that up.
You name it as 4 bromo, 4 chloro. You don't put di because they are not the same. It's when they are the same that is when you use the word di, tri, and tetra. Are you following? It's just like this one. We have different things here now. Is it not? Methyl and bromo, are they the same? No. All right.
Master,
Yes.
so when the lecturer was teaching he said that if you have halogen and methyl,
Yeah.
the same carbon, that you start from one with halogen,
Halogen.
which is bromo. That
Halogen
you start
is
counting
bromo.
from the one, that is you start counting from that is closer to
So the halogen. No, not at
before
all.
the methyl.
You start your numbering to the side that is closer to the subsequent group. Exactly. All right. Shall we?
Yeah.
All right. So if we want to name this now, between B and N, which one comes first?
B.
Now, if you want to name it, you in terms of alphabetical order, you don't consider the preface. You don't consider the word
Preface.
Preface are words added to the beginning of a word to change its meaning. So this die here is a preface. You don't consider this. You only consider the word, the substituent. The substituent there is bromo, not die. Are you following? All right. Between B and N, which one comes first?
B.
So it becomes
Four.
Dibromo.
dibromo.
Dash.
Two what?
Methyl.
Two methyl what?
Enzane.
All right. So it becomes 4,4-dibromo, 2-methyl-enzane. All right, let's name the last one. This one is in a ring form, right? Which is in a cyclic word form. All right, this one that is in a ring form. Whenever it's in a ring form, you use the word cyclo. You use the word what?
Cyclo.
The cyclo there is the base name. Are you following? The cyclo there is the what? The base name. All right. And if you also there is a double bond there, right? And if it's a double bond is what? Alkene. If it's a double bond is what?
Alkene.
If it's a double bond is what?
Alkene.
All right. If you observe, how many carbon is it? This is 1, 2, 3, 4, 5, 6. Is it not 6? 6 is 6 called what? Enzene. 6 is 6 is called what?
Enzene.
So if you want to name this now, you name it as cyclo.
Enzene.
Cyclo what?
Enzene.
Enzene. All right.
Definitely.
Or you can name it cyclo S1E. So any question? You don't consider the preface, you only consider the word, the substituent. The substituent there is the So you can copy that, then move straight to hydrocarbon. In terms of cycling, hello. In terms of cycling, there's when it comes to numbering of carbon, here can be your carbon 1. 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 Are you following? Now, this one now, we are starting our numbering from here. Are you following? So this is 1, 2, 3, 4, 5, 6. It depends on the position where you have the word, the double bond. Okay? Now, this is benzene structure. Hello. In terms of benzene structure, here can be your carbon 1. Here can be your carbon 1, carbon 1, carbon 1, carbon 1, carbon 1. Depending on, is when you now have a substituent group attached to it. Are you following? Now, supposing maybe, for example, we have OH here. Then we have OH here. Then we have H, and H. Now, please pay attention. Look at this now. Your OH there is called hydroxy. True or false? OH there is called what? Hydroxy. If I want to start my numbering now, because I have my substrate group here, I'll start my numbering from here. If there's no O, if it's just one OH, it's called phenol. Are you following? You will do that in your ND2. Okay? So this carbon 1, please no noise. Carbon 1, carbon 2, carbon 3, carbon 4, 5, and 6. In benzene, we call here ortho, meta, para, ortho, meta, Para.
Okay.
Are you following? So it's when you get to your NE2. Now, if you want to name this now, your oxy is found in which carbon? Carbon 1 and carbon 3. Is it not? So if you want to name this, you name it as 1,3 dihydroxy. Dihydroxy benzene. Dihydroxy what?
Benzene.
1,3 dihydroxy
Benzene.
So that's it.
Okay.
Hello. We are asked to draw the structure of the following. Okay. Now you already know how to name structure, but this time around, you are being asked to draw the structure of those things you named. Okay. Whenever you are asked to draw the structure, drawing of structure is more easier than what? Than naming. Now, what you always take note of is the parent chain, the parent carbon chain. Are you following? Yes. You first of all write out the parent carbon chain. Then you now attack the position of the substituent before you place your word hydrogens. Are you following?
Yes.
All right. For the first one, you are asked to draw pentan 2 what? Or. Pentan 2 or. That is, the parent shade there is sent as or pent. Yes. And pent is how many? 5. That means you have to have how many carbon? 5. 1, 2, 3, 4, 5. Is it not? Yes. That means it's 2 or. 2 or is sitting as your OH. That means your OH is attached to which carbon? Carbon 2. Are you following? Yes. So you are going to have what? OH. Either you place it at the down or at the top, they are both the same. Are you following? Yes. So you are done, you are drawing that. So the next thing is to place your what? Hydrogen. So we have H, 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 If you like, place it at the second carbon, yes, it's still the same thing. Are you following? So this is number 1. So number 2. So methyl 1 chloro what? Butane. Now the parent carbon there is what? Butane. Which is how many carbon? 4 carbon, right? Yes. So we have 1, 2, 3, 4. Is it not? Yes. Then you now take note of the position of the substituent. See that your methyl is attached to which carbon? 2. And your chloro is attached to which carbon? 1. That's good. So your chloro is in carbon 1, right? Yes. And methyl is in carbon 2. Is it not? Yes. You cannot place your hydrogen. Yes. So we have hydrogen, hydrogen, hydrogen. Hydrogen.
And I got it. Hydrogen.
So number 3. Ethan 1, 2 diol. Ethan 1, 2 what? Diol. Ethan 1, 2. Yes. Diol or. The parent chain there is what? X. X is how many carbons? 2. Yes.
Why did the methyl come before the chloro when you said alphabetical order?
That's because these are the right at the name. Are you following? Yeah, we are asked what to draw. In terms of naming, you knowing that this naming is what wrong. Yes. On the no, chloro ought to come before what? Methyl. Are you following? Alright, so from here, H is how many carbons? 2 carbons. So we have 1, 2. Alright. Now, diol. That means you are having 2 OH. And the 2 OH are attached in what? Carbon 1 and carbon 2. Are you following? Yes. So here we have OH. And here we also have OH. The place of what? Hydrogen. Hope this one is clear. Yes. So the next one we have 1, 1, 2 tribromoethane. That's number 4. 1, 1, 2 tribromo what? Ethane. What the parent carbon there? X. Is that many carbons? Is that many carbons? So we have 1, 2. Tri means 3. So now you add 3 bromo. And in 3 bromo, they are both attached in carbon 1 and carbon 2. You have 2 in carbon 1 and you add the other one in carbon 2. Not be so?
Yes.
Alright, so we have bromo. And we have what? Bromo. And we have what? Bromo. So you cannot place your hydrogen, right?
Hydrogen.
So hydrogen, hydrogen, and hydrogen.
So can we put the bromo or aja?
As number is in carbon 1. So the next one we have 2 chloro plus 2 in. 2 chloro. Both 2 in. Alright. The parent carbon there is what? Both. That is 2 carbon, right? They say 2 what? That's 4, right? That's 2 in. Don't forget, I said in terms of the in is in which bond? Second bond. I say we are counting carbon to carbon bond. So this is the first bond and this is the second bond, is it not? So we have a double bond here. So and the chloro is attached to which carbon? So carbon 2 is here, right? If you like, place it here, place it here. They are both the same. Are you getting me?
Yes, Papa.
So we have our Cl. So you cannot place your what?
Hydrogen.
Ensure that each of the carbon always carry 4 bonds. Are you following? Ensure that each of the carbon always carry how many bonds? 4 bonds. So how many bonds is left here? 3. That is hydrogen, hydrogen, hydrogen. This one, how many carbon? You need 1. This is 1, 2, 3. How many is left? 1. That is just 1 hydrogen. That's why some students are missing it. Some still place another hydrogen here. At the end, this one will be having how many? 5. It ought to be up test. Are you following?
Yes, Papa.
Alright. So this one is complete already.
Yes.
How many is left here? 3. That's 1, 2, and 3. Methyl what?
Benzene.
Methyl what?
Benzene.
Methyl benzene. So since it's benzene, it's going to be in a cyclic form, right? And benzene is among the aromatic compounds, is it not?
Yes, sir.
Alright. So we have it like this. So the methyl is CH3.
Yes.
You can place it anywhere.
Yes.
Are you following?
Yes.
So we have our CH3. So that's all. Can I place your hydrogen?
Hello? Yes. No.
Yeah. You can. Don't forget, each of the edge you have your what? Carbon. Each of the edge you have your what?
Carbon.
And the next one, cyclohexane. That's BII. It's still 6, right? So that's 1, 2, 3, 4, 5, and what? 6.
6.
So how many bonds? So we have hydrogen, hydrogen, right?
Yes.
Hydrogen, 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 and hydrogen, hydrogen. So this one is known as what?
Cyclohexane.
And the last one is hydrogen what?
Benzene.
So this your methyl benzene is also known as toluene. It's also known as what? Toluene. And your your hydroxy benzene is stated as phenol. So this hydroxy benzene. So put our word OH. That's hydrogen. Don't forget each of the edge, you have your carbon and what?
Hydrogen.
Alright. Hello. Please, I need your cooperation. As you can see, if you look at the back, there's a camera behind you. Your cooperation matters what? Mind the way you make noise. Not if you all give any out, we all go online. And people come